All right, let's get into it. Today, we are going to tackle a huge question in the world of tech. Why do so many programmers, from beginners to pros at Google, absolutely love Python? We're going to see what makes it tick by putting it side by side with a couple of other languages.
So, seriously, what's the deal with Python? You hear about it everywhere. Is it just easier? Is there some secret sauce? Well, to figure it out, we're going to do what coders do. We're going to build something. We'll start simple and see how each language handles the exact same tasks. Let's do this.
Okay, first things first, we're going to start with a rite of passage for every single programmer on the planet, making the computer say, "Hello, world." It seems trivial, I know, but it's actually a perfect first test to see how complicated a language is right out of the gate.
So first up, we've got Scratch. And this is, well, it's about as intuitive as it gets. You're not even really typing code. You're snapping together these visual blocks like Legos. The logic is right there for you to see. When the green flag is clicked, say hello. This is our baseline, just pure, simple intent.
Now, let's hop over to C. C is a powerhouse. It's a foundational language that a lot of other things are built on. But to do the exact same thing, just say hello, we've suddenly got all this ceremony. You have to #include something called a library, you have to define this special main function, and you need all this specific punctuation like curly braces and semicolons, or it just won't work. It's powerful, for sure, but a little formal for a simple hello.
And then you have Python. Just look at that. One word, print, and then in parentheses what you want it to say. That's it. No ceremony, no extra punctuation. It's almost exactly how you'd say it in English. And this right here, this one line, perfectly captures the entire philosophy of Python. Keep it simple, keep it readable.
Okay, so saying hello is one thing, but what about building actual useful programs? Well, turns out every program, from your calculator app to the most complex video game, is built from the same few fundamental building blocks.
You know, you can kind of think of it like the original Super Mario Bros. The entire game world, every single level, is built from just a handful of different blocks, right? You've got your brick blocks, your question mark blocks. Programming is exactly the same idea. You've got variables, conditionals, and loops. If you can master those three things, you can build pretty much anything. So let's start with variables. Don't let the name scare you. They're just boxes, little containers you create to hold a piece of information, like a player score or a username, so you can use it later. Let's see how C and Python handle making one of these boxes.
Okay, look at C on the left. You have to be super specific. You have to tell the computer exactly what kind of stuff you plan on putting in that box. Here, int tells it this box is for integers and integers only. But then you look at Python on the right. You just name your box, in this case, counter, and put something in it. Python is smart enough to just look at the 0 and say, yep, that's a number. It just figures it out for you, removing one little thing you have to worry about.
Next up, conditionals. This is how programs make decisions. It's just a fancy word for if-then logic. You know, if the traffic light is green, then go. Else, wait. This is the core of how software appears to think. So this is what that logic looks like in C. Pay attention to all the parentheses and those curly braces. They're the grammar. They're absolutely essential for telling the computer which chunk of code belongs to which if statement. They create the structure, but you can see how they add a little bit of visual noise. Now, check out the Python version. Where did all the curly braces go? Python does something really clever. It uses empty space, the indentation, to define the structure. The visual layout of the code is the logical structure. And see that keyword elif? That's literally just a shortcut for else if. It's designed to be read like a sentence.
It all comes down to a core belief in the Python world. Make the code so clear that another human can read it easily. It's all about making it simpler.
And finally, our third building block, loops. This is what makes computers so powerful. They are amazing at doing the same repetitive, boring task over and over and over again without ever getting tired. Loops are just how we tell them to do that.
The traditional for loop in C is very mechanical. It's like building a little machine. You have to give it 3 precise instructions. First, you create a counter, I, and start it at 0. Second, you tell it the condition for running. Keep going as long as I is less than 3. And third, you tell it what to do after each cycle. Add 1 to I. It's very explicit, giving you total control.
Python's version feels more human. It reads, for I in range of 3. This basically translates to, for each number in the sequence from 0 up to 3, do this stuff. You're not micromanaging the counter variable, you're just describing the repetition you want. You're focused on the what, not the nitty-gritty how.
So, we've been looking at all these little differences, right? A keyword here, some curly braces there, but what does it all really add up to? Let's zoom out and see why these small choices make such a huge difference for programmers.
Well, all that simplicity creates some massive advantages. For one, the code is just plain easier to read, which makes it way easier to fix and update later. Because there's less boilerplate to type, you can often write your programs faster. Fewer semicolons and braces means fewer chances for a tiny typo to bring your whole program crashing down. And maybe the biggest advantage of all is its absolutely enormous ecosystem of libraries.
So what in the world are libraries? Think of them like a programmer's hardware store. If you need to do something complicated, like advanced math or creating a chart, chances are somebody has already written, tested, and perfected the code for it. They've packaged it up into a toolkit, a library, that you can just grab and use.
In C, you use the #include command to tell the computer, hey, go grab that toolbox from the hardware store. I'm going to need it.
And in Python, you guessed it, a simple, intuitive word, import. It does exactly what it sounds like it does. And Python's collection of libraries is one of the biggest in the world, which is a massive reason why it's taken over fields like data science, artificial intelligence, and so much more.
And this really gets to the heart of it all. At the end of the day, the best tools are the ones you forget you're even using. They just become a natural extension of your thinking, helping you solve the actual problem in front of you. By making readability and simplicity its top priorities, Python tries to be a language that just gets out of your way. It wants to reduce the friction between your idea and a working piece of software. It lets you build.
And that clear path from idea to creation is why millions of people have chosen Python. It lowers the barrier to entry and empowers so many more people to create amazing things. So I guess the only question left is, what will you build first?